name is Joris, as mentioned before, and I work at iText. These are the other developers at iText, a charming picture of all of us. And this was taken just after a team building, so if you're wondering why some of the people look this way, you have an idea. We're a very diverse group, a lot of people from backgrounds that may not necessarily resonate to development, but I think that contributes greatly to the team spirit and also to the product itself. Today I'll be talking about structure recognition, and to start with, I want to give you a brief idea of the discrepancy between PDF and some of the other formats that users are acquainted to. So in PDF you have various standards, and that comes down to the fact that PDF is essentially a container of other information. So you may have text, you may have images in different formats, you can put signatures in different formats, you can embed XML data, etc. And the level of descriptiveness, given the fact that you can do all of these things, varies depending from PDF to PDF and from whatever standard your document adheres to. At the basic level, a PDF only needs to contain those instructions for how a viewer ought to render the document. And at the bottom of the slide, I've put some PDF syntax. For those who are fluent in PDF syntax, this is of course no mystery, but it renders the text appearance and pilot. You can see kerning information, and essentially this is a nightmare if you want to do any kind of structure information, or even if you just want to extract text from it. Because even though this might look clear to us, to a computer, it's not that obvious. Then we come to the expectations, of course. Like I said, I just want to give an idea of the discrepancy. Before I started working in a company that works with PDFs, I didn't think that extracting text from a document would be that difficult. I mean, if you look at something like Office Word, extracting text is not difficult at all. I can just copy paste and it will work perfectly. I didn't think reflow would be an issue. If I drag an image in Word, then of course the content flows around it. And this is of course due to the fact that structure is inherently a part of a document there. If you look at the latest docx specification, it just gives you an XML with coordinates and text and other rendering artifacts. So it means you can also export to various formats, it means you can easily extract data, and it means that you can change the appearance of any logical unit, like a word, a line, or a paragraph. And you can clearly see this discrepancy if you look at Stack Overflow, for instance. A lot of times people ask a question like, why can't I remove this word and have the text reflow around it? Why can't I make this text a different size and expect the document to still properly work? Why is that impossible? Now, before I present a solution, I definitely don't want to give the commercial pitch, but due to the company itself, we are bound to a certain kind of solution and to a certain kind of constraint level. All our products are open source, so we want to present a solution that customers can fine-tune, that they can tweak, and that we are okay with releasing. The idea behind it is also that if the user knows best, then we want to incorporate that knowledge into the process. If our solution proposes something that makes no sense to you, and you are the expert in handling invoices, it makes sense that we leverage your knowledge into the pipeline rather than pretending we know best. So let's get to a more technical level. The solution itself is a mix of the best of both worlds. So each of these steps can be handled by either machine learning or heuristics, and the fact that there are discrete steps means that it's somewhat traceable for the user what is happening. So first we start with recognizing words given just character render information. Then we merge those into lines, the lines go into paragraphs, and then we detect special features. For instance, a paragraph might appear just underneath an image, it might be centered or justified so that its width flows nicely with that image, then we can of course conclude it's an image caption. Similarly, we can try to detect headers and footers, page numbers, etc., and we can exclude those from actual content. Then we can move on to detecting lists and tables, because this is often where the information can be found. If you think of invoices, boarding passes, etc., the information is often in these highly structured pieces of content. From the previous slide, you can deduce that the data structure that we will need needs to be very efficient and very optimal for evaluating equivalence. What we essentially want to do is tell it, okay, I have one character here and another one there, and they are equivalent. And from that, the data structure should be able to deduce that this character that was already equivalent with the rest of the word also belongs to that word now. Similarly for lines and paragraphs. If you don't know this data structure, the disjoint set, or the disjoint set algorithms, sometimes called, that's the tip of the day. It's a beautiful algorithm. It manages to do all of its essential operations like finding equivalence, merging two equivalent things in a number of operations that is equivalent to the inverse Ackermann of number of elements. The Ackermann function grows super exponentially, so that means that the inverse Ackermann function for all practical purposes can be considered a constant, in the sense that the number of known atoms in the universe is less than Ackermann function of 10. So inverse Ackermann grows really, really slowly. The other advantage to this disjoint set is that it maps very nicely to PDF ideas. So you can see the kind of tree that it builds, and this is of course very similar to a tagging structure that you would have in a properly tagged PDF. Now, the disjoint set algorithm tells us how we can merge, but it doesn't give us any ideas on when to merge. And when to merge depends on what is being merged. And I will present two approaches, and it will become clear why I mentioned the corporate philosophy, because these solutions are ultimately discarded based on that. So the first approach is using human logic or heuristics. So we merge two chunks into words if they are close to one another. And close to one another can be interpreted as they are less than a single space apart in the same font. Similarly, we can merge words into lines based on the distance between them, based on whether we detect a break in layout that might indicate a two-column article, etc. The problem with this approach, and I've implemented it, so I know the problem, is that soon it becomes a real tangle of parameters. Because you have users that suddenly use tabs to lay out things, you have ASCII art, you have poetry that flows over a page, and that authors want to flow over a page like that. You might have tables that are actually being used to render lists. So a lot of things that make no sense from this perspective are actually found in PDFs in the wild, so to speak. And before you know it, you have to incorporate all of these rules, all of these parameters, and it just makes the whole solution a clutter that nobody can debug anymore. But what's the alternative? The alternative, which bends the constraints a bit, is that we use artificial intelligence. So as soon as we notice that we have a large amount of parameters, why not use an artificial neural network which incorporates all of these parameters to handle the problem for us? Then if we notice that the network isn't performing well, we can simply train it on more documents or retrain it on our specific documents. So this is an overview of how the solution can work, and I will go into more detail later. We take a PDF, preferably tagged, because we want to have some kind of supervised learning setup, and we convert it either completely to graphics, so turn it into an image, or we convert it to a graphic state like objects, where we say, okay, this character has this font, it appears on this X and Y coordinate, this font size, etc. We feed this information, or rather all of these parameters, into the neural network, and we teach it to output 1 or 0 depending on whether we want these things to be merged or not. After the training period, the network should be able to produce a probability that any new items should be merged or not, depending on what it saw earlier. The deliverable here includes not only the neural network coefficients, but, and this is an advantage to the earlier one, it has an error rate and it is configurable. Because ultimately, whether or not you want to merge them depends on how high you set this threshold. If the network says, I think they ought to be merged with a probability of 80%, it's still up to the user to decide whether or not 80% is enough. Whereas the heuristic approach, you either need to tweak a lot of parameters, or ultimately it outputs a black and white situation where it says, I decided to merge these. If you want to try again, please choose different parameters. The downside of the neural network is that it's not really retractable. ultimately it is still a bit of black magic. You input parameters, you train it, and afterwards it outputs ones or zeros. So let's go into a bit more depth. The first problem when doing this approach is that using any kind of machine learning, and especially neural networks, requires a very large amount of training data. So that means that we needed a large volume of preferably perfectly tagged PDF documents. When we contacted our friends in the industry, most of them thought we were kidding. They didn't think such a corpus would exist. The ones that knew of such a corpus couldn't share it for legal reasons, and other people told us, if you find it, please share it, because we could benefit from it. Of course, there are solutions. We thought, okay, maybe we can build our own. We have a solution that converts HTML to PDF. Why not simply crawl the internet, find all the HTML we can, and convert it into perfectly tagged PDF? The problem is that a lot of JavaScript is in there, a lot of constructs in CSS are in there. You need to support everything perfectly in order to do it. And even then, nothing ultimately prevents the end user from using tables in order to generate lists. People can do the same kind of nasty hacks in HTML as they could in tagging a PDF document. We thought, okay, let's use a corpus that we trust. Why not, for instance, Gutenberg, a large online library that gives you access to HTML of books where the copyright has passed. The problem again is that Gutenberg has a very specific layout, and you are essentially teaching the neural network to recognize Gutenberg documents, which is very great, but not as much if you're interested in teaching it to tag invoices, because suddenly it won't perform anymore. Of course, I do mostly research, so another solution that I came to was, why not simply crawl the internet for PDFs? Google has this convenient function where you can say, find me all documents with a given keyword, and make the file type to be PDF, for instance. Not anymore?
Not anymore. Google doesn't have it anymore. Bing has it still.
Oh.
Google not.
Now, I was about 5 minutes into this, happily grabbing a coffee, being proud of this works. And then my colleague at the other desk says, you do know this is illegal, right? You can't use Google in this way. Ah, darn it. So that had to be deleted, of course. And of course, with GDPR coming into play, you can't guarantee that these documents don't contain any personal information without going over all of them. So ultimately, the solution I thought was brilliant turned out to require a lot of manual work anyway. Luckily, an industry contact came to the rescue. They have actually made a business out of generating, or rather correcting, documents that aren't properly tagged and turning them into properly tagged documents. And they were willing to share their data set with us if we help them kind of make a pipeline for processing documents automatically. So this is more into the actual algorithm itself. We saw kind of the setup of it. This is an example document that was properly tagged, where I have taken the liberty of highlighting everything that is tagged as a paragraph. So you can see that there are a few paragraphs here. It has a 2-column layout, so it's a bit challenging for the algorithm. And of course, I've only highlighted one aspect, but this document also knows where each of the lines are. It knows where each of the words are. So that means that we can feed the neural network this kind of document and say, I know that these are 2 lines, I know the information of each of those lines, and I know that they belong together. Please teach yourself that this ought to be merged. And similarly, we can teach it, these paragraphs are different. Here is the information for both of them. Teach yourself that these paragraphs should never be merged. Now, using a neural network, in this setup at least, requires that we select some features, that we essentially pass judgment on what we think is important when considering when to merge or not. I've listed a few here, like X and Y coordinate, width and height, font size, whether or not the text is in bold, italic, or underline, the difference between X and Y coordinates, but you can imagine other combinations as well.
What is the difference of X and Y? Different to what?
So for instance, if you are asking the network, should this character be merged with another character to form a word, the X and Y difference is essentially this X is that much different from that X. Of course, if the network is deep enough, the network will learn by itself that subtracting X values is a valuable thing to do. But sadly, I don't have a machine learning cluster at my office. This was a proof of concept thing, so I needed this to go fast. So I included some hand-calculated features here, but I don't think this is any real issue in a full setup. Now, like I said, you could include other features as well. You can include color information, you can include hue, saturation, value, you can convert it to RGB, you can include information about the language that a line was written in, so that you can say, okay, this line is written in Arabic and the next one is written in Hebrew. Maybe these languages are indication that the paragraph does not continue here. So all this information can be embedded, and what you choose to embed might influence the performance. I've found that this subset works well enough in most cases. So now that we've done that, we can feed the neural network. What you see here is an actual example of the parameters that I said earlier. So each row represents a data entry in a document, and the columns are X and Y coordinate, width and height, font size, and then a repeat for the second character, and then the X and Y difference, and the 1 and 0 in the end, whether or not it should be merged. So the second to last row, for instance, tells you these characters are 1 unit apart and they ought to be merged. And of course, this is a trivial example because all of them are merged except the last one, where there is a clear gap in X and Y coordinate. Now, once we did this, we can feed it into a machine learning framework. For the purposes of doing rapid development, we chose Weka, which is an open source toolkit for making neural networks. The advantage is that it takes a lot of data formats. You can feed it Excel, CSV, raw data, and it will simply give you a visualization. It will plot nice curves on how the performance is going. It automatically does k-fold validation and so on. And it's available in Java, which is also important to us. But of course, Weka is only meant as a toolkit, and there are better tools that train faster and that are more scalable. But again, for proof of concept purposes, this is more than enough. What you can see here is the final code. So you give it an input stream that represents the model. You tell it, I want you to be this confident before you consider merging two things. And you give it a list of structured nodes. And in the beginning, these structured nodes are, of course, only the individual characters. And you can tell it whether to run until convergence, so merging characters and then going over the document again, or run in a single pass. So we tried this. The benefits, because this approach works in a proof of concept setting, the benefits are that you can now tag an untagged document. And we've tested this for simple documents. It works. For harder documents, it sometimes works, and it sometimes needs manual correction. But again, proof of concept, it needs further work. Currently, it outputs an XML kind of format where it says, I've detected a paragraph here. I think that this is the language, and the characters are at these coordinates, and the entire paragraph has this bounding box. And of course, similarly for tables and lists. It means you can also suddenly do reflow. So this is an example PDF document, an academic paper. It's a 2-column layout. Again, this is a bit more challenging than just feeding it a single flow of content. And what we see here is that we are going to remove the words in this, which is marked in red. And I've marked the word supervised in blue to indicate how it will move as a result of that removal. So in this was removed and supervised shifted. Now the algorithm isn't perfect, it doesn't take into account all the layout information, but it still presents a document that is visually the same, and yet the content was removed. It still performs a justified layout, it still maintains the same kind of font size and font attributes. In the extreme case, why not think of doing an entire layout shift? you have a document that is rendered on A4, you can suddenly render it on other canvases without having to scale the font down or up by an insane amount. So it makes PDF more accessible on mobile devices. It improves accessibility. Another one is that suddenly you can do conversion. So if you have a tagged document, it is very easy to convert it to HTML because these concepts map nicely to HTML. It also means that devices like Siri, like Google Home, can suddenly read untagged PDF documents. You can tell them, go to the next paragraph, and suddenly the thing knows where a paragraph begins and ends. So it's a lot easier for people with disabilities to be able to navigate through these documents that were otherwise not really accessible to them. And lastly, and I think more interesting from an industry perspective, you can do data extraction. So this is an example invoice. Sales told me not to use an actual invoice. So this is an invoice with dummy information to Hogwarts shipping a few barrels of mulled mead. Now what you see here is that the algorithm successfully detects tables. In the first two cases, this is not that impressive. The table was already pretty much there. There were lines to indicate where the table is. The header of the table is in bold and the rest of the table isn't. So there is a good indication of what the table is, for at least from a layout point of view. In the last table on the page, it's a bit more difficult because out of the 6 elements there are actually 4 elements that are in bold. This is not a number that corresponds to the number of rows or the number of columns. There are also no lines to help the algorithm out to detect where a table ought to be. Furthermore, it's in the middle of other text. The background is the same for the entire table, and yet it manages to detect that this is a table. So in summary, this approach works in steps. It recognizes words, then lines, paragraphs, spatial features, and then tables and lists. It uses a disjoint set algorithm, either augmented with heuristics or by working with artificial intelligence and treating the document as a set of nodes that may need to be merged or not. The benefits are that it's configurable, highly configurable, and that you can train it on documents that you want it to work for, and that it has a soft fail mode, that it can tell you, I merged these 2 items with a probability of this amount. So you can inspect the process and you can see why it did what it did. Are there any questions?